This is Microsoft Excel, uh, a simple software program which is used for many people doing only for calculations and inserting tables and making charts. And most of the people don't know that Excel can be used as a powerful data analysis tool, and it is used around the world by scientists, engineers, business analysts. In today's video, I'll show you how this simple looking software can calculate mean, median, mode, variance, standard deviation, regression, even ANOVA. All this from this a simple data set of 10 students. Let's dive in. By the end of the video, I guess you'll understand how powerful Excel can be. You don't have to use programming languages like R or Python to do data analysis, or you don't even have to use Stata, Minitab, or SPSS for advanced data analysis. From Excel, we can do the simple regression, we can do ANOVA and analyze data, uh, which most of our software can do so efficiently and so cheaply. Let's see what can we do now. Uh, Here you can see a data set of the 10 students from class 12 of a government technical college. The That is serial of in the first column, that is serial of 10 students, and in the second column, it is mentioned the names. First one is Arafat Hussain, and last one is Imran Hussain, and they are mentioned here. The 10 students, their names are mentioned in the second column. In the third column, we can see their age is mentioned there. It's written there, each of them, their age, and Arafat Hussain is 17 years old, Mahmudul Hassan 18, and Imran Hussain is 20 years old. And in the fourth column, their corresponding heights is mentioned there in centimeter. Like, for example, Arafat Hussain, who is 17 years of old, is 166 centimeter. His height is 166 centimeter. Now, here we can see uh, some terms, mathematical terms are written there like mean, mode, standard deviation, median, and variance. From this data set, we determine how can we determine the uh, mean of their ages, mode of their age, and standard deviation, median, variance from Excel formula and functions. Let's see, what can I do? We have to use like average function. We have to use the average function to get the mean of their ages. 19.1. The mean, the average of the students is 19.1. And the mode is we have to write the function mode. s- That is the single most frequent value we get from this function dot s and gl. Now we will get the range from C4 to C13. So the 17 is the most frequently written here. Now we get standard deviation. For standard deviation, we write std ev dot s. Now you select the data range and we get the value 1.66 or 67. Now we get the median. For the median, we write the median function, then we select the dataset range. 19 is the median. Now we get the variance. To get the variance, now we do one thing. We write a var dot s. Now we select the range of the dataset. Now we get the variance. I guess if we want to get the decimal 2 point, we have to select number. We have to select number. Now, let's get the name in the middle. Now, if we want to get the height, the median for heights, mode, standard deviation, we just have to extend it here. Now we get the value uh, like this one. We have to get it from here. Equals to, we have to get the average. So average we get 170. Now we get the mode. It doesn't work like this way. Now we get the mode. Mode for single cell. 166. It is mentioned twice. The frequency is 2. Now we get a standard deviation. STD EV dot S. We get the standard deviation. Now we get the median equals to median. We get the median 170.5. Now we get the variance equal dot S. We select the range of the data set. Now we get the value. Like we want to get the value in numbers, two decimal points. So two decimal points and get them in the middle. Now we get the value for the mean, for the mode, for standard deviation, median, and variance for age and height of each of the students. Uh, Now we know that the average of the student's age is 19 and average of their height is 170. So this is a simple form of data analysis. Now uh, let's see. Can we get a regression equation from this table or ANOVA? Can we know the statistically is this data set is statistically significant, or can we predict from each data from the regression analysis the age of any students, or uh, is there any can we find that is there any correlation between the age and height of the students? Let's see. For this, we have to go to the data analysis. By default, there is no mention of data analysis here. So we have to go to the options to find the BVA portions. Let's see options. Click to the options and go to the add-in. Click there and you'll see the analysis tool pack VVA. Now go. Now check it and click OK. And now we see the data analysis. The data analysis tools has been uh, found in the ribbons in the right side of the ribbon. We can see the data analysis part. From this portion, we can do the regression. Let's click here. Now, what do you want to get? Histogram, uh, uh, correlation, covariance, regression. I would like to find the regression here and click in the regression. And we have to predict the height. So the value of height should be here. And now x. From the x will be the age. From the age we can predict the height. And this level, now it will uh, residuals, feed line plot, and we get we get a regression table in the uh, another sheet, new worksheet. Click OK. And now here we get the plot for is if the line fits here, we get the summary, and the multiple R. The R square is 82.2, and adjusted R is this one. The intercept 115.532, and p value. What do we get the p value? The p value. So there is no decimal. After the decimal point, there will be two decimal point. There is lower than two decimal point. The h p value where is given this one, and lower 90%, upper 90%. The residuals we get there. So we get the ANOVA and regressions summary, and we can write the equation here. Uh, so what can we write here? Let's see. We can write this a height equals to heights in centimeter. Height in centimeter equals to what's the intercept? Intercept is 115.54. 115. So 115.5 115.54 plus, now we see the coefficient of the age, which is 2.85. 2.85. Now it is multiplied by their age in years, by which we can predict the height, the height of a student. If we know the age, we can predict the height of the student through this regression equation. Regression equation. So from these regression equations, we can write that if the height is uh, if the height is this one, now the intercept coefficient plus 2.85 into If the age is like 18, the height will be 166.86. Now we can see if the age is 18. Uh, yeah, 18, 167. Or yes, yes. If the age is 18, 166 or 168. Very approximate. Only for 166, there is a minus one, and there is a minus uh, plus one. So it's very near to the actual value. So from this model, we can predict these values. Now we see, we interpret. Now here we have seen that this is a very powerful tool. We don't have to use the Python or our programming language for data analysis. We can easily use Excel as a great data analysis tool. For we can now understand that in Excel we not only can do calculations, we can do graphs, the graphical interpretations. We also can do data analysis like regressions, ANOVA, and we can determine the mean, mode, standard deviation, and many other things. Let's interpret them. We can see the height. The height here. The height is 19.10. That means that the average age of the students is the average age of the students is 19.1. The average height of the students, the average height of the student is 170 meter. 170 meter. The mode, the most weight is most frequently mentioned. The most frequently mentioned is 17. If age is mentioned how many times? 17 is mentioned once, twice. The frequency is 2. So hence the mode is 17. Now height. There is a single value of height, 166 centimeter. It is mentioned once and twice. Hence the mode is 166. That's now standard deviation. The standard deviation is 1.66. Now from we can understand that the uh, value of mean, if we uh, 19 plus minus 1.66, from this value we can get the values for age of age students. It's very near to the 1.66. From it is very 1.66 approximate to the mean, to the average value. And for standard deviation is 5.23. The height, the average height is 170 centimeter. So plus minus, that will be 5.23, 5.23 centimeter, 5.23 centimeter. Now we got the variance. The variance is 2.77. The median, the middle point. The middle point is also 117. It's similar to the average. The median of the height is 170.5. 170.5 centimeter. Now the standard deviation from standard deviation, we can understand that we didn't explain the variance. The variance. The variance means that the uh, value of the H is 2.77 around the uh, mean or standard deviation, and the variance 27.33 means it's around uh, 27.33 centimeter around the mean of 170 centimeter of height. Now we'll interpret the regression analysis and ANOVA. From this regression analysis, we can see that like we can say summary output. The summary output. From summary output, we get R squared value is uh, 82.82 uh, 30 around. Approximately the R squared value is 82.30. It means 82% data is statistically significant. So we get a very powerful and very significant data. And the age is very significantly related to the height. The higher the age, the higher the student's height. The lower the age, the lower the student's height. Like if the age is, for example, the age is 22 and height is the highest, 178 centimeter. If the age is 17, the height is the lowest, 166 centimeter. So there is a very strong correlation between age and height of a students of class 12 of a government technical college. Now we can see the F value. The F value is 37.18 and the significance is 29. F value is good. So data is also seen very significant here. Now we will see the regression equation. The height can be predicted through the 155 plus 2.85 into age, and we have calculated earlier. If the age is 18, we get the height of 160 around 167 centimeter. So data is statistically very significant, and if the age is 22, we get a higher value. And there the p value. The p value of age is point 0009. So it is lower than 0.05. It's lower than 0.05. So data is statistically very significant and is strongly correlated with the age is very strongly correlated with the height. There is a very strong correlation between this data and it's a very powerful set of data. Now we can understand that we can easily uh, do the statistical analysis, the data analysis in uh, Excel. We don't have to use the other powerful softwares or expensive softwares to do that. We can easily do that in Excel very easily. Now, I hope that I will continue this data analysis and chapter and the Excel the other Excel functions, formulas, and what can we do calculations in Excel. I will show them um, if I get the time. Thank you, everyone. Take care.